Unfortunately, my new headphone is not behaving so well, become very temperamental. Maybe I need to go from the 3.5 jack to C type because the audio jack in the laptop is there, but somehow the headphone is not working properly. So hopefully this sound is okay. I'm going to get the adapter and then go back to the headphone because the sound is really much better with that one. But let me record this with this Bluetooth device and see how the sound is. I have to basically shout a little when I do this. And I'm not a loudspeaker. If you know people who know me, they'll tell you I speak very low. So it's a bad habit or and the doctor told me that happens because I have a wrong connection from my ear to my sound box. So I hear things very loudly. So when I talk loudly, I think I'm speaking too loudly. So yeah, anyway, why do you need to know all that? Well, it's the morning. I'm just telling you a story. I'm old and now I'm beginning to talk more nonsense. So this is a nice paper by Suhas, Ramesh, Kripa, and Boos. Well, Boos is at Berkeley. Ramesh used to be her He's postdoc. Now she's in Australia. She did a paper with me before when she was just a kid and so on. This is a nice paper because it's talking about the influence of monsoon low pressure systems on South Asian disasters and implications for disaster prediction. We have, discussed low pressure systems elsewhere in the monsoon and S2S courses where low pressure systems are related to the cyclonic features that are born in mostly the northern bay, sometimes in the Arabian Sea side as well, and they trek across India and they bring up to 60% of the rain. So you have the background circulation, southwesterly monsoon, the monsoon trough, and then you have monsoon intraseasonal oscillations coming up in the ocean and then setting off these. Well, there is a relation between mesos and low pressure systems, and there is a very strong relation between low pressure systems and active break cycles because you have many more low pressure systems during the active phase. So they are all related, and I keep talking about intrinsic time scale being the active break period, since all these things fit into that period, and since El Nino, La Nina, and all global warming all tend to project onto active break duration, intensity, frequency, etc. Uh, it's all one framework, and there seems to be a stationary corridor along which these low pressure systems run and haven't been much affected by global warming in the sense that that pathway seems to be, the corridor seems to be persistent across all regimes, right? So transient atmospheric vortices called monsoon low pressure systems generate a large fraction of total rainfall over South Asia and often produce extreme precipitation. Here we assess the influence of these storms on the occurrence of disasters using information from the Emergency Events Database, EMDAT, that we geocoded and then associated with LPS tracks. We show that more than half of hydrometeorological disasters over South Asia during the summer monsoon are associated with these LPS events. Weak LPS, which are called monsoon lows, occur more frequently than stronger LPS called monsoon depressions, but the stronger LPSs produce a larger number of disasters. Furthermore, although many prior studies have shown that peak rainfall in LPSs fall southwest of the vertex center, the disasters are concentrated on the northern edge of the LPS track, so some detail there. And this also happens along the Himalayas and the upper basins of Ganga and Brahmaputra rivers. You will see the figures in a minute. Observations show a sharp peak in rainfall on the day of disasters, confirming the physical link between LPSs and these hydrometeorological disasters. A similar peak in rainfall is found in weather forecasts made up to 5 days before the disaster, suggesting that short-term precipitation forecasts can be useful in disaster preparation, of course, prevention and recovery and mitigation and so on and so forth. right? So I'll put this podcast in a couple of courses in the S2S predictions in the monsoon and also in new findings in climate change because it's a topic that fits everywhere. Monsoon low pressure systems, LPSs are, they call it monsoon low pressure systems, LPS. I always like to say LPSs, monsoon low pressure systems, are the principal bearing. So LPSs are the principal rain-bearing systems observed over South Asia during boreal summer, forming and propagating within the larger continental scale monsoon circulation. These atmospheric vortices have a horizontal scale of about 2,000 kilometers and last for about 3 to 6 days. They form most often over the Bay of Bengal and propagate northwestward over the core monsoon zone, sorry, with peak precipitation falling southwest of the vortex center. So imagine a counterclockwise vortex, southwest and northern edge. So where the rain falls, where the disaster happens, we'll see. Individual LPSs are typically classified as weaker monsoon lows and stronger monsoon depressions stronger monsoon depressions based on the strength of their winds. The total population of LPSs is collectively responsible for a large fraction of monsoonal precipitation over South Asia, and individual LPSs are often associated with extreme rainfall. A recent study showed that over 80% of the extreme precipitation events over central India occur on days when an LPS exists. So extreme events also have become larger in spatial scale, and there are nice studies showing that there is a secondary vortex from the Arabian Sea and the monsoon low pressure systems on the Bay of Bengal combine to produce these large scale extremes. Quickly, a summary of EM dataset that we talked about for disasters over South Asia during June to September over 1990 to 2019, a nice 3 decades or so. Total disasters, hydrological disasters out of them, meteorological, and geophysical and biological. I won't go into the details, but you can figure out what they are. And the number of disaster events is shown in each category with the number of disaster locations in parentheses. So total disasters over so many places. Hydrological disasters cover the most locations. Meteorological, geophysical, and biological drop in the number of locations as well. So numbers of hydrometeorological disaster events and subsets associated with the LPSs can also be, you know, uh, uh, derived from the CMDAT. Just to remind ourselves, EMDAT is the Emergency Events Database. I even forgot, even though I read it several times. Disaster events associated with LPSs out of the total hydrometeorological disasters, that's more than 50%. Disaster events associated with depressions and disaster events associated with the lows, depressions and lows, and number of depressions and number of lows. Okay, so just let's look at the geographical distributions, spatial distribution of disasters, and location of hydrometeorological disasters in red circles associated with monsoon LPSs and the tracts of LPSs shown in brown. This is the corridor that I talked about, which has remained stationary for over a century. So it's geographically trapped, orographically trapped, some other dynamic trapping, etc. have to be figured out. But you can see that there are many born on this side, but almost all are born on this side. And here you are looking at the location of disasters relative to the LPS center. So obviously around the center, but some are also farther away. But the further you go, the number drops here in terms of the total. The disaster counts again, you can see the number of disaster locations associated with monsoon LPSs in terms of fraction of days in the June to September season on which the region is under the influence of LPS within 800 kilometer of an LPS track. Okay, and this is the number of LPS days. So that's the fraction of days in which June to September season that I just read. So number of disaster locations and this is the relative risk. You have to be careful about how it is defined. The risk of disasters due to the presence of LPS, all in individual 2 degree by 2 degree subregions. Relative risk greater than 1 indicates that risk of occurrence of disasters is increased due to the presence of LPS. So they have used a method. Risk definition is not unique, but their methodology will tell you exactly how they did it. But just keep that in mind because they are mainly focusing on past disasters, LPSs, and the relation between them. So that basically constrains the definition of disaster. It's not about vulnerability, exposure, and so on. Fraction of disasters associated with LPSs. You can see that the fraction of disaster locations associated with LPSs, and so this is Ah, the way the labels work, it's always confusing. All LPSs, depressions, and lows. So basically, you are saying again what we said in the table that the low pressure systems, including lows and depressions, explain large number of the disasters. What about the global precipitation mission precipitation for disaster events? So when you have LPS in millimeters per day, on day zero of the disaster, you have high rain, and for non-LPS, the distribution is not so obvious or less clear that the day since disaster is the location of the highest rain. Well, it is kind of, but the amount is smaller here. This is 20 millimeters per day with a distribution that is not as strongly peaked on disaster day zero of uh, the LPS. So here 30 millimeter per day and here just over 20 millimeter per day. Do you want to argue about that? Not really. ECMWF precipitation forecast for disasters associated with LPSs. So 24-hour, 72-hour, and 120-hour. You can see 120-hour has larger distribution or uncertainty or standard deviation, variance, whatever you want to call it. But basically, the skill gets better when you get to 24 hours, which is this bluish line. And you can see days since disaster also is shown here. So what is it? Time series of ECMWF model forecast daily rainfall at the disaster location for the disaster events associated with LPSs. Forecast for 24, 72, 120 hours before each day in the time series, and B is for forecasts made 24, 72, and 120 hours before the day of the disaster. Okay, so slight difference. Day zero corresponds to the day of the disaster, the day the disaster occurs. The shaded region spans the 25th and 75th percentiles. Plots are for years 2007 to 2019. A shorter period is used basically because they may have the forecast available only for those days. Nonetheless, the argument would be that the skill is there, but can and should get better because of the close association between LPSs and disasters. Pakistan doesn't have as good data as India does, but they have managed to squeeze out something. And Pakistan has been getting flooded every year since 2010. And we have, I'm involved in some work with the Chinese colleagues, Bao Xing Li, showing that the Middle East warming is affecting the winds here and hence the extreme rainfall and even heat waves over northwest India into Pakistan. So this is showing the study of two disaster events. LPS track and disaster locations filled with circles for 2017 Mumbai flood, which was a disaster, but the number of deaths were reduced compared to the 2005 uh, flood, which killed, I think, maybe 1,700 people or so. They learned their lessons and did much better in 2017 and the 2010 floods. Position of LPS at the start of the date of the disaster events are indicated by crosses. So here you have the cross. I hope they are talking correctly. Okay. Start of the disaster, yeah. So also shown are the time series of daily rainfall from GPM observations and ECMWF forecasts. So you can see that ECMWF longer lead forecast is 72 hours, expected very heavy rains. So GPM, on the other hand, did much lower amount of rain, but you have to be careful because uh, grid resolutions and pixels, everything can matter. Calibration of the GPM itself can matter, which is always not very good in every place. Nonetheless, you can see that the ECMWF compared to the day zero does pretty well for 24-hour forecast. The 120 hour doesn't capture the uh, coming event at all. 72-hour overestimates it, but 24-hour does well. So this is for Pakistan's 2010 flood, which started the count in terms of how badly off they are by now. They are getting drowned every year, and they have tremendous heat waves before that as well. So you can again see that the ECMWF 24-hour forecast for day zero, not so bad at all. And then it did something different than GPM, but all the forecasts underestimated the rainfall. But again, the scale of the rainfall here was very large. So you have to be careful about how this paper looks at the GPS versus ECMWF forecasts. You get the idea that LPSs should be forecasted better, which comes down to MESO forecasts as well. Many efforts are underway, and it's tricky. It's not as doing as well as MJO, let's say, which is the eastward propagating interseasonal oscillation or interseasonal variability, whereas mesos go north and then are on the ocean and then they spin off these cyclonic vorticity systems that go northwest over India. Here we associated monsoon LPSs with the occurrence of natural disasters in South Asia. We used geocoded disaster information from EMDAT to associate uh, hydrometeorological disasters with LPS for the rainy season of June to September. Disasters are most heavily concentrated along the Himalayas and the upper basins of the Ganga Brahmaputra rivers. The Himalayas are the foothills where you often get very heavy rains, landslides, and so on. But when you have warm monsoon winds coming and climbing the mountains, you have hail issues, you have extreme rains, you have cloud bursts, you have all kinds of things happening because of orography mixed with warming and moisture supply. We found that more than half of the disasters are associated with monsoon LPSs. Furthermore, the disasters associated with monsoon depressions are more frequent and geographically widespread with stronger precipitation and as compared to the disasters associated with monsoon lows. Although LPSs occur somewhat frequently, with around 15 forming each summer over South Asia, their association with disasters is stronger than what would occur by chance. So it's not just a random event that disasters happen and LPS suppose happens to pass by. So it's much more systematic. Specifically, the relative risk of a disaster occurring when an LPS is present within 800 kilometer of a location is larger than 1 in most of our domain, with relative risk exceeding 10 in many regions. So now you have to go back and see whether the rain on this side and the disaster on that side, say after vortex, say something about the wind versus the rain impacts on what is causing disasters. We found that disasters occur mostly along the northern edge of the main cluster of LPS tracts, while peak rainfall in LPS is well known to lie southwest to the southwest of the LPS center. We confirmed this location of peak rainfall in our tract dataset, so this discrepancy is not caused by anomalous behavior of the LPS in our dataset. Given the geomorphology, fluvial transport, and groundwater hydrology, all control how precipitation is related to flood characteristics, it's not surprising that there is a spatial offset between the peak LPS rainfall and the disaster location. Furthermore, we illustrated how human exposure may contribute to such offsets, with peak population density located hundreds of kilometers to the north of the peak precipitation in a storm-centered composite of LPSs, which you can see, go and see in the supplementary material. But you did notice that all the rivers are being shown here just for good measure, so that even if, this is the main corridor of the LPSs, right? And let's say rain is more to the southwest, but population density and rivers, catchment areas, etc., are to the north, and there's some topography of the central Ghats as well. Okay, so again, the main message, of course, is that sorry. Observations obtained from GPM show a sharp peak in rainfall on the days of disaster. This peak is more prominent for disasters associated with LPSs than for non-LPS disasters, which suggests a physical link between LPS and hydrometeorological disasters. Numerical weather prediction model forecasts also show a similar peak in precipitation for disasters associated with LPSs. This peak is clearly visible for forecasts made even up to 5 days before the disasters, 120 hours, although the peak rainfall decreases with increasing forecast lead time. But in the ready, set, go framework, maybe the skill can help to prepare for the disaster that may happen, but how to allocate resources is very tricky when the skill is not very high. Okay, these short-term forecasts of LPS tracks and precipitation might thus be useful in designing disaster early warning systems and in improving disaster preparedness. So a lot of no-regret decisions can still happen. Although it was not a focus of our analysis, we briefly examined the occurrence of fatalities in LPS-associated disasters. The mean number of fatalities in disasters associated with monsoon depressions is higher than that in disasters associated with the lows. But the uncertainties are large enough that these differences are not distinct when considering the 95% confidence interval of the means. A distinct difference is found between the average fatalities in disasters associated with the multiple LPSs and the average in single monsoon lows. This highlights the importance of considering the impacts of LPSs traveling through the regions that were recently traversed by another LPS, though more work is clearly needed to understand the relevance of geophysical hazards such as elevated river and groundwater levels and the evolution of social vulnerability. Future work could also assess the possible influence of LPS characteristics on the severity of disasters as well as the influence of co-occurring phenomena like the boreal summer interseasonal oscillation and uh, boreal summer intraseasonal oscillation BSISO that are thought to alter LPSs and their associated precipitation. So as I said, there's a clustering of LPSs into active and break. Active periods have many more LPSs than break periods, and mesos are definitely related to those. The other point that's not made here is that a previous LPS can increase soil moisture and, you know, enhance rainfall in the next LPS through soil moisture, local recycling of the previous rainfall's soil moisture. Okay, so let's leave this here. And obviously, I'm being brief as usual, but you should go back and read the nice paper and the references if you are interested in more details. Okay.